Selectivity in Diels-Alder reactions. Have you got it? This short video quiz assesses your ability to determine the major product from a Diels-Alder reaction, including stereochemistry. Prior to working on this quiz, you should already have an idea of how to do this, either from class discussions or from reading the textbook or other sources, such as the Wikipedia page for the Diels-Alder reaction. This quiz consists of 3 questions. It's meant to be taken after you have studied the material and think you understand it, maybe before a quiz or exam. During the presentation, you will be asked to pause the video to at least try to solve the problem yourself, and only then to continue. It won't be hardly as effective if you jump to the solution immediately. Okay, here we go. Number 1. In each case, indicate the expected major product of the reaction between the specified diene and dienophile. In each case, 2 enantiomers are possible. Just draw one. Pause the video while you answer this question. Write it out on paper. Come on back and I'll show you how I would do it. Okay, here we go. The idea here is to put these 2 together. I like to start by always adding all the hydrogens around the central part of the diene and the dienophile, where the reaction is going to occur. And then I'm going to bring these together with all the atoms that are in the middle going back. Now in this particular case, it doesn't really matter on the diene because there's 2 hydrogens on each carbon, so that's not going to be a big deal. But the key thing here is that the 2 that are on the dienophile, this one on the right, both go the same direction. That's the stereospecific nature of the Diels-Alder reaction. Okay, for the second one, we have an H and a CH3 on the dienophile. I won't draw the ones on the diene this time. Same idea as before. I like to get that 6-membered ring with the double bond in right off the bat, so that's done. Now, it's these 2 groups. They're going to go back. So it's the hydrogen in the back and the methyl group in the back. There we go. In the case of this last one, we also have some groups around the diene. So let's get all these H's in. And now it's these groups right here, these 4 hydrogens, they're going to go back. Once again, get that 6-membered ring with the double bond in. I've got a methyl group over here, methoxy, which is not going back, which means it's going up. And I have the groups over here, this 5-membered ring, and my hydrogens are going back. All right. That is what we call the endo addition, and that is the predicted major product in the Diels-Alder reaction. Okay, how'd you do? Next. Number 2, in each case, indicate the expected major product of the reaction between the specified diene and dienophile. Again, you can draw just one enantiomer. Note that C includes aspects of stereospecificity, stereoselectivity, and regioselectivity. This will require consideration of delocalized charge. Notice also that I haven't drawn these out in such a neat way ready for the Diels-Alder. It's your job to line these up so that you can produce the correct result in the Diels-Alder reaction. Pause the video while you answer this question. Come on back when you're ready, and I'll show you how I do it. Okay, we're back. First one. All right, we've got to get this diene in the S-cis conformation, like this. And it's going to take me a little bit to figure out where I am here, but I'm going to put this methyl group up here, Notice it's trans, like that, and that's what I'm depicting here. And then the methoxy is on the next one. Okay, that's that one. And then my dienophile. All right, now we do this again. We're going to draw the H's, and put them together so that all those H's go back. There's a six-membered ring. It's these H's going back. So we're going to put that methyl up. This methoxy is on a double bond. Don't draw any wedge to it at all. No hashes, it's just on the double bond. And then complete the five-membered ring with those H's in the back. And again, that's the endo product. Okay, next one is kind of interesting. We're using an alkyne for the dienophile, no problem. We'll start again, get the diene lined up on the left. Okay, first let's get the diene lined up and get the methoxy on the right carbon. It's the carbon next to the CH2. Okay, and then over here we have an alkyne, which won't have any stereochemistry because it's a triple bond. Now, just like before, I'm going to add the hydrogens. In this case, let's go ahead and draw the other enantiomer. It's actually the more common one that's drawn in a situation like this. In this case, what we're going to do is take those middle atoms and actually make them go forward instead of back. So they're going to get the bold like that. And the OCH3 and the H are going to go back. And now what happens on the right? Well, basically what happens is we've got another part of this ring, another ring, which is formed. This is the actual new ring from the Diels-Alder. Double bond there, no hashes, no wedges on these because they're on the double bond. And there we have it. It looks a little funky, but that's okay. It is a valid drawing. It does depict the endo. I will draw it a slightly different way, the way you'd probably see in a book, which is kind of looking at it from this direction. Usually the way this is done is by drawing a boat conformation first. And connecting it over here. Now the H would be sticking out here, the methoxy's back here. And don't forget to draw that last double bond over there. A little bit more the way you typically see it in a book. And the way to do that is when you see this extra ring system like this in the diene, go ahead and make the middle part go forward rather than back so that it becomes this sort of bold-faced line. Okay, I'm going to erase what's on this slide and give us a little bit more room to work on this C. First, we're going to get these lined up. Now, the way I do this, I always have the electron withdrawing group in the in this, so what I call the northeast or the 2 o'clock position, sort of on the outside of the reaction. That's the way the endo is going to work. Now, here's the problem. The problem is that the diene is not symmetrical, and also the diol is not symmetrical. So we have two possibilities. It's either that they're coming together like this, or like this. Okay, and the question is which one of these is preferred. We do this by looking at charges in the delocalized resonance contributors of each of the two, the diene and the dienophile. One way to do this is to separate the charge based on, in this case, probably the carbonyl group, and see where it goes. Okay? And we're going to keep going until we get to the end of the line. And we see that the plus charge ends up at this final carbon. We're doing the same thing over here. Actually, in the dienophile, we want to start with the oxygen here because we're going to try to develop a minus charge somewhere on the system. So what would that mean? That would mean we donate a pair of electrons from this oxygen to this system right here, right? And that's going to show up on this carbon, 2 carbons away from the oxygen. But that's not one of our key carbons. These are the 2 key carbons that are going to react in the Diels-Alder reaction, right? These 2 right here. So we need to move that charge over there as well. Like that. And now we see that in this reaction, the partial minus charge is next to the carbonyl group. And in this particular case, as drawn, look, these 2 are not lined up. The partial positive charge is over here. The partial minus charge is over here. Drawing this up here on this version, we'd have the partial positive up here and the partial negative down here. And this is what we mean by lining up the partial positive and partial minus. So of our 2 possibilities, it's this first one that's going to get the job done. Okay, so we only need to consider this first top one. We'll draw the dienophile on the left, and we'll draw the product with the bridge in the front. Okay, what are we going to do about this stereocenter out here? Okay, the idea here is that all of these groups in the inside now went up. So that's our hydrogen coming up along with our bridge. And there you have it. That's the endo product. And if I were to draw this the way we often see it in books, it would look like this. Hydrogen up on the same side as that oxygen. And there we have it. A little tricky, for sure. Take a look at that, really go over that, make sure that you can do that sort of analysis. All right, on to the next. One last question. Here's your challenge. At a group meeting, your research supervisor suggests making the compound shown below as a racemate, as a possible drug candidate. You jump up and say, I have an idea. Suggest a compound that can react with itself in an intramolecular Diels-Alder reaction to give this structure. What stereochemistry do you need in the reactant to get the 3 stereocenters shown here? All right, this is a good challenge. Think about it. Take some time. See what you can do. You have to deconstruct this product back into the appropriate diene with the right stereochemistry and put it together again and make sure you get this. Okay, good luck. Pause the video, answer the question, come on back. Let's see what you got. Okay, we're back. How are we going to do this? Well, let's start by identifying where the Diels-Alder is reacting. It's this 6-membered ring right here with a double bond. So that means it came from a situation where the double bonds were here. There's a single bond here. We're making these 2 bonds, and there was a double bond over here. So let's draw that out. Looks like that. Now, I have arbitrarily chosen a stereochemistry around these 2 double bonds. In this case, what have we got? We've got a Z configuration for this oxygen and this methyl, and over here we have an E. But that's the question. Which way do these go? All right. Well, it's apparent that we want this methyl group to go up and this hydrogen to go up. And those are the 2. Okay, I've drawn the hydrogens in around that system. And the point is that we want all of these to go up, don't we? Or at least that's how it's going to go. All of those are going to go up. If we do the correct Diels-Alder, this methyl group is going up, this hydrogen is going up, and over here, this hydrogen is going up. But look, if you look here, this methyl group is up. So that's actually wrong. This is not the stereochemistry. And what we need to have here is to have this 2 switched. So our actual starting material looks like this. There we go. That's our starting material. Again, let's just double check it. If we have the hydrogen here, and we do the Diels-Alder reaction, We're going to make this bond right here, this bond right here. Okay, and methyl is going up, hydrogen is going up, and the methyl is going up. And we got it. Okay, well, I hope that was helpful, and I hope you've got it.